Welcome back. If you're looking for the absolute bleeding edge of artificial intelligence, completely free of the marketing fluff, well, you're in the right place. Today, we're doing a deep dive explainer on the highly anticipated MiniMax M3 model. The entire developer community is literally buzzing about this thing, and we're going to break down exactly why.
30 cents. Yeah, you heard that right. 30 cents per 1 million input tokens. That is the incredibly disruptive launch promo price for what's being touted as a true frontier-class model. I mean, that's just a tiny fraction of what you'd normally pay for top-tier Western models. But, the big question is, does the performance actually justify swapping out your daily driver?
So here's our roadmap for today. We're going to meet the MiniMax M3. Check out its secret sauce MSA, compare the benchmarks versus reality, look at some AI video magic, dive into the pricing revolution, and then wrap up with our final verdict.
All right, part 1, meet the MiniMax M3.
Let's look at what this brand new open-weight model from Shanghai actually brings to the table, because the claims here are massive. M3 is currently the only domestic model combining 3 absolute frontier essentials. We're talking native multimodality for text, images, and video, a staggering 1 million token context window, and frontier-level performance on complex coding tasks. Plus, they're promising an open weights release in about 10 days, which honestly is a huge win for the open source community.
Moving on to part 2, the secret sauce, MSA. Let's see how they actually make a 1 million token context window usable without breaking the bank. Time to bust some jargon. At the heart of M3 is something called MiniMax Sparse Attention, or MSA. Think of it like a super smart librarian. Instead of rereading an entire library of encyclopedias every single time you ask a question, MSA instantly identifies and reads only the relevant chapters. It's a lightweight top-K router that partitions key-value data into blocks, isolating just what you actually need. Now, why does this matter? Well, traditional dense attention forces a model to calculate absolutely everything, which creates a massive bottleneck. Other models try compressing the data to solve this, but then, they lose semantic quality. MSA, on the other hand, processes raw, uncompressed key-value representations using a really smart memory layout. It completely bypasses those traditional bandwidth bottlenecks without losing any nuance.
So what does this actually mean for us? It cuts compute costs down to 1/20th. You're getting a 9.7x speedup in the prefill stage and a massive 15.6x boost in decoding generation. And it does all this while matching the quality of full attention. The crucial point here is that these huge speedups finally turn a million token context window from a sluggish marketing spec into a snappy, actual production reality.
All right, let's jump into part 3, benchmarks versus reality.
Because we all know models can be heavily optimized for benchmarks, we really need to compare those jaw-dropping headline claims against unfiltered developer experiences out in the trenches. Starting with the vendor-run benchmarks. On SW Bench Pro, which tests real-world software fixes, M3 scores 59%. That narrowly beats GPT-5.5 and Gemini 3.1 Pro, and trails just a hair behind Claude Opus 4.7 at 64.3%. So on paper, it absolutely has a seat at the frontier table.
Grounding this in reality, MiniMax ran a pretty wild internal test. They asked M3 to optimize a highly complex CUDA kernel on NVIDIA hardware. Over 24 hours, with zero human intervention, the model autonomously iterated, made nearly 2,000 tool calls, and actually achieved a 9.4 times speedup. That kind of autonomous workflow requires immense long-horizon focus.
And independent reviewers are largely backing this up. AI consultant Thomas Wiegold ran M3 through a pretty strict gauntlet. He praised its flawless code audit of his own website, specifically pointing out that it didn't just invent fake problems to look busy. He ranked its web design output right alongside closed frontier models, flat out calling it a real winner.
But, to provide some necessary whiplash here, the unfiltered community on Reddit shared some real frustrations. Several developers complained that the model overthinks simple tasks. In one poker simulation, it spent 40 minutes second-guessing itself, essentially folding to its own shadow. Another user flat-out called it a gaslighting model, claiming M3 invented fake bugs during a code review that didn't actually exist. Yikes.
Synthesizing this polarized feedback gives us a much clearer picture. On the pro side, M3 is a phenomenal coding workhorse. It excels at web design, and it holds long context beautifully. The cons, though? It sometimes lacks that final polish, struggles with fluid abstract reasoning, and can get caught in these token-burning loops where it overthinks a simple prompt, which obviously drives up your costs.
Moving on to Part 4, Directing AI Video Magic.
M3 isn't just a text coder, so let's explore its native multimodality through its Video 01 Director API. Right out of the gate, M3 generates cinematic video clips at 720p resolution and 25 frames per second. It supports videos up to 6 seconds long, offering text-to-video, image-to-video, and a really useful subject reference mode to keep facial features consistent across your footage. And the crazy part? It does this for just 50 cents per output video.
What's absolutely brilliant here is the control system. Developers don't have to rely on vague prompting and crossing their fingers. You can input natural language camera commands directly into your prompt using brackets. Want a tracking shot? Just type in push in for forward depth. You can combine commands like pan left and pedestal up to precisely direct the cinematic movement of the AI camera. It is incredibly intuitive.
All right, let's pivot to Part 5, the pricing revolution.
We really have to talk about the financials because MiniMax's aggressive pricing strategy is fundamentally shaking up the developer ecosystem. The pay-as-you-go API pricing is frankly startlingly low. The standard rate is 60 cents per million input tokens, but with the launch promo, it's just 30 cents. And if you hit their prompt cache, it drops to an absurd 6 cents per million. They also offer subscription token plans ranging from $20 to $120, giving you literally billions of tokens to play with.
The true impact really hits when you compare it directly against the top-tier Western model like Claude Opus 4.7. At $5 for Opus inputs versus 30 cents for M3 inputs, M3 is more than 15 times cheaper. I mean, this completely changes the math for running long-horizon autonomous agents that process massive code bases over hours or even days.
Which brings us to Part 6, the final verdict.
So, we've unpacked the architecture, the hype, the gritty reality, and the aggressive pricing. Based on all the data, the smartest strategy right now is to adopt a hybrid model workflow. Route those cost-sensitive, high-context tasks to M3. Use it as your affordable heavy lifter. Then reserve Opus or GPT-5.5 for tasks requiring high-level abstract reasoning and that final nuanced polish. Also, a quick heads up, make sure to verify the exact terms of that OpenWeight's license when it drops, since previous models did have some commercial restrictions.
I'm going to leave you with this provocative thought. As open-weight models become this capable, this natively multimodal, and this incredibly cheap, are you ready to trade the polish of Western frontier models for the raw, cost-effective power of MiniMax M3? How will you redesign your own workflows to take advantage of them? Thanks for joining me for this explainer. Keep learning, keep experimenting, and I'll catch you in the next one.